All right. Good morning. Appreciate everybody joining us early this morning. This is the Ashrae 90.1 2013 electrical energy monitoring presentation. It's a mouthful for sure. I'm Billy Sanders, here with Levine Electronics and Electric. I actually cover from a sales standpoint Alabama and the Panhandle of Georgia. We've been doing some projects focused around Ashrae 90.1 here for the past couple of years in Alabama. So we've got a little bit of experience in the solutions involved for these types of projects. Just to clarify, this is not a Ashrae 90.1, all of Ashrae 90.1 presentation. We are specifically going to focus on the electrical energy monitoring portion of this. We know the whole thing can be pretty confusing, but we're just going to focus on the energy monitoring portion. All right, so the outline is we're just going to do an overview of what the power monitoring portion of Ashrae is and what those requirements are. We'll look at a project example, talk about some of the metering options, and then we'll talk about the solution that L3 has that we've been using with our contractors here over the past couple of years. Then at the end, we'll take some questions, and if we have any discussion or questions like that, we'll go through. So 8.4.3 section within Ashrae is the electrical energy monitoring section. So what the monitoring section says, you can read there below, you got to have measurement devices installed in new buildings to monitor electrical energy use for each of the following. So one, we've got to have total electrical energy. So your power coming into the building, they want to know exactly what all that energy is or what that total load is. Yeah.
Are you going to share this with us?
Yeah, well. Oh, yeah. Yeah, just making sure it was up there. When you said that, I was like, it's not up on the screen. Yeah, absolutely. Yeah, I could share this with you. It's not a problem. These are the different sections that they want metered separately. So total load, HVAC systems separate, interior lighting, exterior lighting, and receptacle circuits. Okay, so we've got 5 different separations that we have to do within this monitoring. So for buildings, it says for buildings with tenants, systems shall be separately monitored for the total building and excluding shared systems for each individual tenant. Okay. The requirement is 25,000 square feet, so any buildings larger than 25,000 square feet. And then for multi-tenant facilities, if they're, I believe, somewhere, if it's less than 10,000 square feet of common space, you're exempt. We'll hit the exemptions here in a second. Below, you see there's an exception that when you have all these different loads on these panels, up to 10% of the load for each category outside of total electrical energy can be allowed to be from other electrical loads. So it's not 100% separation. So if you have, for instance, if you have one panel that you're monitoring and it's all HVAC, but for some reason you've got some parking lot lights that are on that panel, as long as it's less than 10% of the total capacity of that panel, then you're still within the regulations. Okay. So recording and reporting is the next portion of this. So not only do they want you to separate each one of these loads and actually meter it, you've got to record a minimum of every 15 minutes and report at least hourly, daily, monthly, and annually. So, you know, and the question always comes up, well, who's going to monitor this? Well, it's going to be up to the facility. As far as I know today, there is not a monitoring or a board or anybody that's coming around to check. Once this is installed and up and running, that's going to come and make sure that you have that documentation. But what I am finding is as you go in and these projects are being installed, then whoever the person in charge from an inspection standpoint, the county or the local, whoever your authority having jurisdiction is, will have to come in and they're going to make sure that that's actually meeting the requirements.
And these are laws, right? The state of Georgia and Alabama.
It is part it's not a law, it's part of the building code. So each state has adopted, and each state is different. So most everybody that's going to be on this call is either going to be from Alabama, Georgia, or Florida. And depending on what state you're in is what energy code they have adopted. When you look at you think you can go to pretty much any state's website from a building standpoint and codes, and it will tell you, hey, here's the building code that you have to adhere to, here's the energy code you have to adhere to, so forth, so on. So Alabama, from a government or a public funded standpoint, state funded standpoint, for the last 2 years has already been requiring, and this is the 2013 version. So here we are 7 years later, and authorities, the different jurisdictions are just now adopting a 7-year-old code. So each state is going to be a little bit different of what they actually have to adhere to. From what I understand, the state of Georgia, starting this year, has adopted Ashrae 2013. So the state of Georgia, for any commercial building that's larger than 25,000 square feet, has to adhere to this part of Ashrae. So, yeah. So, yes.
All right, for the data collection, has there been any standards there, or are people trying to do it just with a paper copy, or could this be stored in the cloud? Or what has been your experience with how that's being stored?
Well, it's going to have to be stored electronically. I haven't had anybody storing it manually by paper. There has to be a system in place to go in and read this data. There is, yeah. So, and then the last part of that, you see it says that the system shall be capable of maintaining all data collected for a minimum of 36 months, right? So 3 years worth of history on energy usage, right? So it's a pretty long time, but this type of data doesn't take up a whole lot of room. Yeah.
And so this shall be reporting to who?
Well, that's a good question. The projects that we're doing is we're just collecting the data. We're making sure that if someone were to come in, again, there's no governing body over this. There's not a jurisdiction police that's going to come in once this is up and running and a year later come in and check to make sure this data is there. There is nobody at this point. It's up to like I said, the authority having jurisdiction. So the local code enforcement officer, whoever that happens to be, whether it's the county or the city or, whatever, from a building standpoint. So that's going to be your electrical inspector. It's up to them to make sure that now, and let me back up. When you're as a engineer designing a project, you have two options. You have International Energy Conservation Code, or you can go with Ashrae. It's up to the designing engineer. Actually, I take that back. It's up to the architect to decide which one you're going to use from the beginning. I believe that is correct. But once you decide, that's what you have to go with for everything. HVAC, because there's different requirements for HVAC loads and how you're designing the space there. And again, we're just touching on the electrical energy monitoring portion of Ashrae, but there are also lighting and receptacle load requirements. So watts per square foot for a certain type of building in certain spaces that you have to adhere to. And so there's a lot that goes into how you have to design from an energy standpoint a certain type of building. So as we go in this, we're just talking about the energy monitoring portion of this and how we solve that problem. So because it's been a pretty big issue, and we'll talk in a minute about some of the different ways that I see this come across from a project standpoint. The engineers will, just because it's something that they have to do, it doesn't change anything with the way that the building operates. Specifically talking about the energy monitoring portion. It doesn't change how they're going to control their lighting. It doesn't change, the watts per square foot. It doesn't do any of that. It's something that you have to put in there to be able to collect the data. And from my time actually doing consulting work, that was always something that came at the very end. And 9 times out of 10, you had some standard specifications. You said, provide this. And it was up to the contractor just to make sure that it went in. Because reality is that once this goes in, most likely it'll never be looked at again. Until 10 years down the road when they start having some governing body that you're going to have to report to every so often, which could come at some point in time. Okay.
Do other sections of standard address alternate energy sources, gas?
Do not know the answer to that question. I have not, like I said, I'm not an Ashrae 90.1 expert all the way through. So we focus just on this piece of it for the most part, and the electrical side. So as far as I know, there could be, but again, it's kind of focused around the larger commercial buildings. So, all right. So, hopefully y'all can see this up here. So this here, and I've got drawings upon drawings from different consultants that kind of show this in different ways. But this here is one particular consulting firm. I believe they probably use this as a standard for the energy monitoring. They put it on the drawing, and this is what they use every single time. And just make modifications to it. So this is a system that Siemens puts out, and it's got several different parts and pieces. So let me see if I can get there's a spotlight right there. Okay, so what this is a meter collection panel that Siemens has. So what you do is you've got CTs in each one of these different panels. So as you can see here, this particular person put receptacle loads. So these are all receptacle loads here on these panels. And then over here, you've got your HVAC loads on all these panels. You've got to go all the way down. And if we go back, so the question was, you got to go all the way down to receptacle level. And let's, so let me show you. Well, receptacle load. So here are the different categories that we have. We've got to have total energy. We've got to have HVAC systems separated, interior lighting separated, exterior lighting separated, and then your receptacle circuits have to be separated. Not down to individual receptacle, but right, as an aggregate, all receptacle loads. Okay. So
Well, that's why you can't do that.
yeah, so typically from a commercial standpoint, okay, so the question was asked, typically when you're designing a building, couldn't you have electrical and receptacle or lighting and receptacle loads on the same circuit? from a commercial standpoint, that is true in houses. Residential, yes, you can have that all the time, and 9 times out of 10, that's the way it's done. From a commercial standpoint, the engineers usually have separate circuits. So your receptacles will be on one, your lights will be on a different one. A lot of times it's easier from a wiring standpoint that way, and it's easier from a lighting controls as well. So there are multiple ways that we can look at actually separating these loads. So this particular individual said, let's go and separate by panel our loads. So you can see here there's PPA1 and B1, C1, and C2. All these panels individually have HVAC loads only on. Again, as we remember back to our requirement, you can have up to 10% of other loads on these panels and it still be considered HVAC loads. Receptacles on this side, what this one is not showing is lighting panels. So from a design standpoint, that's still a great way to go. If you can separate out from a panel standpoint and separate the loads out per panel, that makes the monitoring a lot more cost effective when we get to the monitoring side. Because what we end up having is, from a contractor standpoint, they see this and 9 times out of 10, they don't know exactly what they're going to be providing. They just know they got to provide it. So they throw X dollars at it without even getting a quote because they don't know who to get it from. And then when it comes time to actually implement it, there's not enough money in the project to actually get it done. So we've run into that before too, where we're scrambling at the last minute to try to get something in and operational because the switch, usually it falls up under the panel manufacturer. Whoever's providing the electrical panels and the switchboard is what this is going to fall under. And they put some money in there for it. And then at the end, the contractor's saying, all right, I need it to work. And now we're scrambling to put something in to actually make it work. So this particular system, as you can see, each panel has separate CTs just on the main, and you have CT cabling, current transformer cabling that comes back into this collection panel. Off of that, you've got, this is just like an HMI interface that is going to be I don't know if it's touchscreen or not, but this is a Siemens product. And then on the right side is a separate data logger that you can connect to it as well. So think computer of some sort with some storage on it. Hard drive, I don't know exactly what it is. We don't use those in the projects that I've done. So in this instance, if we think about it from a practical installation standpoint, you've got electrical panels spread out all over the place in a building. You've got one collection panel as being this circuit collection panel here that's going to be located somewhere. And now you have to find a way to run CT cabling from each panel all the way back to this location. Okay. Then it's not just putting this in either, where there is a misconception of, okay, well, I just got to put this equipment in and we're good to go. Well, that's not the case. Once it's installed, you've got some programming that's going to have to be done in order to be able to pull the data up for each one. The system here, when you put it in, is dumb. It knows that this is a load coming in, but it doesn't know what kind of load it is. So if you're going to actually report this to somebody at some point in time, you've got to be able to tell the system, okay, well, here's your HVAC load, and this one is this. So there's programming involved. And then you've got to actually commission it on site to make it work once everything's installed at the end of the project. So all these parts and pieces have to come together. Typically, we get involved with projects during the bid phase. So the engineer has designed this project. It's gone out to bid, And now we're working with the manufacturer, whether it's GE or Eaton or Siemens or whoever it is, to put together a metering package that they can include to their distributor as part of the price of the electrical equipment that's going in. Okay, so so this is one way that I've seen it, portrayed on drawings. I've yet to see a system like this installed. It's very cumbersome. If you ask me, trying to get it there, and the contractor's got a lot of conduit that they're going to have to run, and then you run into CT cable links, and how you're going to run those and make sure they're not too long. So all these are issues that we've got to address. CTs will be in the panel itself, or they could be at the breaker, depending on how the system is designed. Could be in the same room and come off of the switchboard. But you got to get the CTs into the switchboard, ahead of time, or it's, when it's being built. So this is one way to do it. Let's see. We'll hit that one next. We'll kind of talk about real quick there are a couple of other options. So you can have separate meters for each individual panel. They could be Modbus, Ethernet meters from a communications standpoint. That can be serial RS-485. And these are a couple of the meters here. These are single circuit meters that are going to be at the level of the panel. So these are only going to be covering the main of each individual panel. Okay. Again, it's going to be along the same lines as this one, to where you're going to have CTs here, either in the switchboard at the breaker where it comes off and they're being fed from, or inside the panel itself, wherever the panel is located. So you're going to have CTs coming in for this one, going back to this meter. Now, the GE AMP1 is a integral meter. It's a whole panel meter that GE uses and is installed at the manufacturer when the panel is built. So the CTs are put in when the customer receives this on site. It's installed. This meter is already in the panel board at the very top, and then it's just a matter of getting the data from that meter. Okay, so it's already going to be operational. The other way that we can do this is from a whole panel standpoint, is the switchboard, and GE in particular, has some breakers that are in their main switchboard that you have the option of doing metering on them. So they're the Receptacle breakers, so they're intelligent breakers. And if you add the metering option on there, then we can get current and voltage and power out of those. So we connect those via RS-485 back to our system in order to pull that data. So those are some different options. And these are all what I call single circuit meters. So if the design of the system has each panel has its own separate loads, and you don't have mixed loads between panels, these are all great ways to go about doing that, or possible ways to go about doing that and getting that data back. But there's also another way. We run into this some as well, to where maybe you've got a panel that's out in the middle of nowhere as far as the building goes. Maybe it's a lab that's all the way down at the end somewhere, and it's just not practical to put in 3 separate panels down there to separate your lighting and your receptacle and your HVAC. It's just a waste of money to do it that way. Well, in that standpoint, we have multi-circuit meters. Okay, so the EPM 4500 on the right typically can be used in a main switchboard as well from GE, to where this meter itself will meter multiple branches within the switchboard. The various industries on the left is going to be from a smaller panel board standpoint. So what this is, we'll go in like a 42 circuit panel, and on the left and right here, these are installed in the panel board. So this is all done at the factory when it's being built. You actually can monitor each individual. You got CTs here for each individual 120 volt circuit. Okay, so if it's a 3-phase, you got 3 of them. You know, it covers all 3 of them. It's a single phase, then it separates all of it out at an actual circuit standpoint.
Actually on that.
This CTs are on these PCB boards right here. They're mounted in the panel board, and when the contractor wires this up, they bring their wire down and go through the CT and hook it into the breaker. Okay, so where this is a possibility, let's say it's an afterthought, and from a design standpoint, and the engineer has got mixed loads all over the place, and like, oh no, now we've got to monitor this, and we forgot it. You can put this in here, and then we can handle the separation at the metering and monitoring level. Now, there is an issue with that in some cases. There's a cost associated with that. So let's think about this. If I have, and typically the projects that we've been working on are anywhere from 10 to 30 panel boards or metered boards or metered areas. Okay, so when we look at this, if they're, let's just call it 20. You got 20 panel boards. They're all separated out. So we're going to monitor or meter these at the main breaker or at the main level of each panel. Okay, we're not going all the way down to individual circuits. So now, if we're going to do it that way, the engineer has separated the receptacle loads on this panel and the HVAC loads on this panel, then we've got 20 different meters that we're metering. Okay, and for each one, we're going to have watts, volts, and energy, total energy. Okay, so that's 20 times of doing this. And remember, we've got to go in and we've got to program this. So we've got Modbus memory maps for each one. If it happens to be a meter we haven't used yet, we've got to build those from scratch. We have to do the commissioning on site and make sure that we're reading from each one, getting the data into the meter and into our data collection. If each one of those 20 panels now has one of these various industries multi-branch monitors on it, now we're down to 42 per panel times 20 that we have to go in and program. And we have to tell the system that this circuit on this panel is is lighting load. This circuit on this panel is receptacle load. So now from a programming and commissioning standpoint, there's a lot more time that has to go into doing this, which adds up to a lot of money in the end. So what we like to see from a cost standpoint for the owner and being able to fulfill this and to fill this requirement and keep the cost down is to try to separate the loads as much as possible beforehand, rather than separating them out at a monitoring level. So that's what we like to see. We're not always able to do that. I have seen several different times to where the engineer did it on all of them but one, because that one panel, like I said, was out far away. It just wasn't practical to do it that way. So
What you're basically saying, extra panel is cheap programming.
Programming is not cheap. Yes, it's not cheap at all. But if you did this one, it's not a big deal. Much easier to do it, for one than it is for 20. So that's something to keep in mind there. So those are the different meters, the way that we can do this. There are systems out there that use a protocol called power line control, where basically they are using the conductor of the circuits to transmit communications to get the data back. The issue that we've seen with that is you have to have these transponder boards or devices at one end to be able to change, to convert that over. It doesn't seem to be as clean of a installation and ease of working with it and commissioning standpoint as the system that I'm about to show you, kind of show you how we handle that. We like separating our communication cabling from our power cabling, makes it a little bit easier for us, and we don't have all these other pieces that we have to interface with. Okay. All right, so now we're going to get into how we at L3, how we are providing a solution for this. So what you see now is our what we've been using from an HMI. So it's a display, because there are times where we have to display the data locally, as well as provide it to a building automation or a building management system. So we have found this solution to be a complete all-in-one HMI historian protocol converter. It's got everything in one. Okay. This HMI panel, as you can see here on the back, actually has, you can add some different cards. So if we needed to go through and add in some extra IO for whatever reason, we could do that. But really all we're going to do is we're going to build an enclosure that's going to house this. It's going to have some terminal blocks in it. And I'll show you a drawing in a second that I did just to kind of show how that cabling is routed together to get back here. But all the meters are 98% of the meters that we do are serial RS-45 serial Modbus communication. Okay, so we do get into occasion where we have an Ethernet, but for the most part, it's all serial. It makes it easy because the breakers, if we have breakers that are metering, then those are going to be serial. If it's this EPM 4500, it's going to be serial Modbus. The various industries is serial. We can do serial on the EPM 7000 as a standard, and then this GEAMP1 is all serial. So it keeps it very easy because that protocol has been there, and that media has been there for an extremely long time. You get into an issue where sometimes you get Modbus Ethernet, sometimes you don't. So coming up with the solution that we could use every single time, no matter what we ended up with from a design standpoint, was something that was very appealing to us. So we ended up coming up with this HMI all-in-one deal. And as you can see here on the right side, there's an SD card slot, so we can put in an SD card and store as much data as we want to. Okay. So that's the HMI. Here is the solution and the way that we would wire this. So here you'll see our 12 panels, multiple different levels. And you have to kind of think about this from how the electrical cabling is going to be installed in this building. You've got multi-level, and you're going to be connecting these electrically with conductors, but also from a communication standpoint. But you can use the same chases and go through the same way. So here's our metering combiner cabinet down here. All this cabling that I have shown here is your Modbus RS-45 2-wire Belden or equal type cabling. We like them to be daisy chained. If it's a small enough project, then you can pretty much daisy chain all the panels together. But logistically, from the location of everything, normally we end up with a couple of different branches, 2, 3, maybe 4 branches We don't like to have from a star topology type standpoint on this. It will work, but we like them to be daisy chained as much as possible. But what you got shown here is we're daisy chaining our serial cable between all these different panels on this side, and it comes down to our metering cabinet. We have terminal blocks within the metering cabinet where these can be landed, and then the same thing on the other side, and it comes down. At the bottom, we've got, as you can see, it's Modbus Ethernet or BACnet or whatever we got. So we have instances to where we just need to store that data locally in our metering cabinet. So we would store it here within this HMI, and we would display it on this HMI. So when we provide it, we provide programming time to do screens here that will show the data. And so there are times where it's going to be localized to just our cabinet, but there are also times where we got to provide it to the building EMS. So what's really cool about this particular all-in-one solution is we can convert within here to any protocol we need. So this has our BACnet protocol built in, so we can convert that over and just finish a project in Auburn, actually, on one of the new buildings there, engineering building, to where we had to provide BACnet over to the Johnson control system. So at the time, we were using a different solution, and we ended up having to add a separate BACnet converter within the panel on top of everything else. So we got into every project we were looking at. It's like, all right, what parts and pieces do we need for this one? Well, do we need BACnet? Do we need this? Do we need to, do I need to show it locally, or do I just need to get it to the building EMS? So all these, every time we were having to figure out which one, what we were going to have to do, what solution we need to provide. With this, we provide it every single time, and no matter what the project is, if it changes halfway through, it doesn't matter. We can still do it with this product. Okay. So we talked about how everything's going to kind of be wired together. So now let's talk about the system parts real quick. Meters, which we talked about, they can be single circuit meters or they can be multi-circuit meters. It doesn't really matter as long as it's a meter for us, and as long as we can communicate with it via RS-45 serial Modbus communications. Okay. We got a note here, and we talked about if the switchboard happens to have breakers that have a metering option, so they're what I call a smart breaker, then we can use that instead of a separate meter. So we've done that before. 2-wire belting or equal serial cable that's going to be daisy chained between the meters to the combiner cabinet. We also talked about star topology. Branches are okay. We like to keep those as at a minimum as much as possible. And then the metering combiner cabinet contains the following parts. So this is kind of when we sell and put together this metering cabinet, these are the parts, and we've got it down to be a pretty simple installation. It's a wall-mounted enclosure. Depending on the location of that, it can be a polycarbonate enclosure, it can be a steel enclosure. It really doesn't matter. Usually a 12 by 12 or a 18 by 16, depending on the size of the HMI that we're going to use. Terminal blocks, we need 120 volt power to that panel. And then if we happen to have some meters that are Ethernet Modbus, then we can put in a network switch in there. We're going to bring those in to combine all those together. So, and we don't run into that a lot, but we do run into it sometimes. The next part is the Ethernet cabling from the metering combiner cabinet to the building EMS, if that's part of the requirements of the project. Talking to the building EMS, then we would need that Ethernet cable going over to wherever that tie-in location is. So from an install standpoint, there's not a lot that has to be installed. You can use, the electrical contractor can use the same chases that they're already using for the conductors that are going back to the main. And I didn't say this, this panel 9 is pretty much always located in the main electrical room. Wherever the main switchboard, the main feed coming in for the building is where this is going to be located. So all your electrical branches are going to be fed from there. So use the same chases and the same routes to get your serial cable back to this panel. And then we can connect it in. Programming is the next thing. We talked a little bit about that, but as part of this solution, we provide programming for all the HMI screens that need to be used or shown there on the HMI, as well as doing the memory maps. If it's a lot of times, if we're using the GE products that I showed, we've already got those memory maps done. So it's from a time standpoint, there's less time involved, less money involved than if we got to go and create those from scratch. But we can, and we have to do it for each meter type. And once we do that for a meter type, we have it from then on. But we do programming that's typically done before we get on site. While the contractor's installing the panel at the site, all this can be done. And then we always provide on-site commissioning for each one of the projects. It's always included. The idea is you've got to make it work. We have had a couple of instances to where we were just asked to provide equipment. The equipment was provided, it got installed, and when it got time to finish the project out, the contractor says, okay, now we need to make this work. When are you coming out to do it? And that was never included. Now we're scrambling to go and actually get that part done. So we don't do that anymore. If we're going to provide a quote for the equipment and the programming, then we're also going to provide as part of that the commissioning. So we're going to go on site and we're going to make sure that everything's up and running, that we're pulling data from every single meter into the monitoring system, and that the data is available and it's being stored, and we can show somebody how to get it out if they need to. And then the last part is if the requirement was there for us to interface with the building EMS, then what we will do is we will provide the addressing and the Modbus maps for our system. So again, we are converting over from Modbus serial to the building EMS system, with usually over BACnet. So there is some type of conversion that's done within the panel or within our HMI there. We will provide documentation to the customer so that they can give it to the building EMS supplier, as Johnson Controls or whoever it is. That way they know how to get that data out and provide it to that system. So that's all part of our package that we put together. So it's a pretty complete package. We don't miss anything when it comes to this. And again, we're always involved. It's always best to get us involved during the bid stage or even the design stage. We're trying to move up and get in front of the consultants to help when this goes out for bid, that this system is there, and it's much easier to get a quote on it and include it from the very beginning than trying to do it at the end. And so we're working on that right now. Questions? Let's see, I probably need to, I'm gonna have to unmute this. Oh, we do have a couple of, we got a couple of messages here on the chat. I've got one here local I'll answer first, and then I'll get to these. Michael, would you have what question?
My question is actually approved. It's online. Are you seeing either architects or clients requiring Ashrae 9.1 or?
Most of the ones that we see is Ashrae. Now, the reason that we see Ashrae, or that I've been seeing that mostly, is because in Alabama, the funded projects by the state. So a lot of the ones at Auburn University, there've been a lot of schools. So university buildings, elementary schools and things like that we've done, the state requires you to use Ashrae 90.1. So in Georgia, and I've got some consulting friends, and from what my buddy told me about what he chooses, he said you can choose either one, but Ashrae, from a whole holistic standpoint of meeting the energy code from a design standpoint, Ashrae is easier to comply with than the IECC. So that's why they're using Ashrae more than the IECC. So, all right. So we also had the question, how does this apply to industrial facilities? As far as I know, there is no requirement in an industrial facility to meet any energy code. You go and do a project in an industrial facility, you don't have a local inspector coming in, electrical inspector, like you do from a commercial standpoint. So you still have to meet certain codes and things, but from an energy standpoint, it doesn't apply. Let's see. So we have serial communications. How do you overcome the 4,000 feet distance for RS-45? That's a good question. So far, I have not had to be concerned with that. The projects, like I said, that we're doing are to date, because this is just now becoming a requirement in Georgia, are government buildings in Alabama. We have not had the issue of being over 4,000 feet yet. So when we do, we will put some type of relay converter somewhere, something in there, that would help boost that signal and get over that distance. The last question is, what does the aggregate screen look like for the data? I don't have a picture of that right now, and they're custom. There's not a standard one that we're using right now. It's custom per building. We kind of show electrical single line, and again, the touch screen, the HMI that we're using, comes in various sizes, 10 inch up to 15 inch, I think. So depending on what the project is and what the requirements are, we might go with a larger screen and have more space than we would on a smaller screen. So it's custom for each job. But again, what we're showing is real-time amps, volts, and power, and then we're using a historian to where you can extract that data from a time standpoint and look at it over a month or a year or whatever. And you can usually do that, via Excel or whatever, some type of data program like that. Let's see, got a couple more. Can it be an applied curve or just data points by period? It depends. Again, depends on the project, and it can be any of the above. Again, we are logging this data, and there are data points. So for every 15-minute time frame, it's taking a snapshot of what the current data is, and then we can extract that data. We can give a curve over time. We can give it pretty much any form that you want, as long as we know when we're programming it. We can also export all that data in Excel and provide templates to make it look like anything you want it to. What format is the data stored in? Does it support trending data, alarm event logs, etc.? What type of historian? Yes, if you extract the data, it will be in a CSV format. The HMI, yes, we can do trending data, which is what the historian portion does. The historian, the product that we're using is a Redline graphite HMI panel that has the built-in protocol conversion, as well as the historian side of it. And we just build the screens custom for that. So Unfortunately, I don't have a picture of what that looks like because there are so many different variations that we can do. But we are working on trying to make that more of a generic so we can repeat that every single time as well. So it's been a learning curve when this first came out a couple of years ago and having to comply with it in Alabama. We've gone through about 3 different variations of a solution to finally come to this one. And what's really great about it is it doesn't matter who the manufacturer is of the meter. It doesn't matter any which way that you can put it together. It doesn't matter as far as our system's concerned. All we need is we need serial cabling going to the meters back to a central location. And then we can take our solution, install it. We can do the programming on it and pull the data from any meter that we've got. So it's what I would consider the only universal solution that's out there. There are lots of proprietary type solutions out there. From a cost standpoint, I don't know what that would look like for some of these others. I think ours is probably one of the most cost effective and best solutions that's out there. Question, Michael says, can the historian be installed on a customer's computer so they can build screens and use the data as they wish? Possibly. We would, yeah, I mean, anything is possible. We can do pretty much anything that you want from like this is a complete custom system. So we can do that. We would have to look at the individual project to see exactly how we would go about doing it. But yes, it's absolutely possible. Any more questions locally? Got 18 people. So, yeah. Yeah, it's not gonna work. Any more questions? If there are any more questions, I'll give a couple of minutes to get them in. We got about 4 minutes left till the end here. But I'll wait a couple of minutes, and if you got one, you can throw it in on the chat. Yeah, this will be posted on the website, our website, www.l-3.com. So we'll try to get it up in the next, probably this afternoon, we'll have it listed up there. Yes, I can share the recording as well.
We're going to be quoting this to a manufacturer or a contractor.
Typically, it is quoted to the equipment manufacturer, who provides it as part of their package to a distributor, which then is quoted to the contractor. But we are technically selling it to the distributor. But the equipment manufacturer has to provide it as part of their package. And GE, this is the solution that we're using with GE. So.
Square D over there, right?
We're dependent. We do a lot of Schneider, we do Siemens. We're a bunch of Schneider and Siemens guys. So.
Yeah.
Well, we're going to wrap this up. Everybody, appreciate you coming in today, being on the call. If you have any questions, again, I'll go back and my email address is here on the front. So feel free to give us a call. It's also listed on our website. So if you got any questions, feel free to reach out.
Thank you, Billy.
Yep. You have a good day.